previous lesson, we were talking about the cell, and we kind of draw the cell and we label a few organelles such as the nucleus. We also talk about the mitochondria, which is responsible for respiration. We talk about the endoplasmic reticulum. We talk about the ribosomes and also other organelles. But today we're going to focus on a specific organelle. Sorry, not a specific organelle, but a specific structure of the cell, and that is the cell membrane. The cell membrane plays a very important part into the function of the cell and also the survival of the cell. I'm just going to write this C-E-L-L-M-E-M-B-R-A-N-E. So what does the cell membrane does is that it allows for materials to enter the cell and also for materials to get out of the cell. However, not everything can be allowed or everything can be given out of the cell. Certain things must be allowed, so it acts like a security system that allows certain things out and allows certain things in. The method that the cell uses is one. Actually, it can use all three at the same time, or it can use one at a time. There is active transport or passive transport. Active transport basically is where the cell uses energy to transport materials into the cell. So I'm going to write the word energy. And in passive transport, there is no energy used. So again, active transport uses energy, passive transport does not use energy. So we're going to start by looking at passive transport actually. And passive transport, because it does not use its energy, it is the way that the cell will tend to prefer, not using too much energy, so it can reserve the energy for other functions. So passive transport involves it can be done in two ways: diffusion and osmosis. So let's talk about diffusion first. So if we have the cell, for example, and say there is a lot of solid particles or solute into the cell, eventually molecules or these particles will start to diffuse or move out of the cell, so that, I'll move over here, so that you'll have a kind of a balance. So if you have 1, 2, 3, 4, 5, you'll have 1, 2, 3, 4, 5. So it kind of evens out. And that is the whole purpose of diffusion. It's basically moving things from where there's a lot of them to where there is less. So diffusion is, and I'm going to write a little definition here so you guys can use this in your study notes, and that is diffusion movement of particles from region of high concentration to region of low concentration. So again, diffusion is a way in which a cell moves things. Not only the cell, our body moves a lot of things by the process from one place to another using diffusion. And diffusion is a very common process that you probably observed, or is a phenomenon that you observed, but you never really took the time out, or you never really had a formal definition aligned to that. For example, if you are standing in front of the classroom, or I was standing in front of the classroom and I was about to spray a bit of perfume, eventually you will smell it if you are at the back of the classroom. So there you'll have particles of the perfume moving from where there's a lot around me to where there is less around you, so it can have an even distribution. So the cell uses this same mechanism, where if there's a lot of particles outside of the cell, it will move into the cell. If there's a lot of particles into the cell, they'll move out of the cell, so they have an even distribution. The next type of passive transport is osmosis. So how is osmosis different? Osmosis is different because it is the movement of water from a region of high low solute concentration to a region of high solute concentration. So the word solute might be a little bit confusing. So solute is basically solid particles. So here again, let's refer to this, to our cell diagram, to see how this mechanism works. And you have your nucleus. I always like to draw the nucleus because it kind of represents the cell a little bit, or it looks more like a cell. And say we have solid particles. Say for example, this is sugar. Eventually what would happen is that water will move outside where there's a low solute or no solute concentration into where there's a high solute concentration. Similarly, if we have another cell and we have solute here that is in high concentration means high amount, water will move from where there is from where there is a low solute to where there's a high solute concentration, so it'll move out of the cell. So in diffusion and osmosis, the similarity between the two processes is that both of them is the movement of particles without any use of energy. The only thing that determines whether things are moving in the case of diffusion is basically where there's a lot of particles, the particles are actually moving, or the solute is actually moving in diffusion. In osmosis, liquid or water will move, and the water will tend to go into a place where there is a high concentration. Similarly, or a phenomenon that you have probably observed is that if you have sand, or you're sand near the beach, eventually water will move into the sand, and you think and you say it soaks it up. But what is happening is that water is moving from where there is a lot of water into the sand where there is a high solute concentration. Finally, let's talk about passive transport. And active transport, my bad. Transport. An active transport is where the cell, our cell model again, and cell basically, what it does is that it uses energy. So say for example, there's a particle here and it's too large to pass through the semi-permeable membrane. So what semi-permeable means is that there are small spaces in the membrane that allow for these particles to pass. But what if the particles are too large? What will happen is that the cell will use energy, and there's a protein here. I don't want to go too much into the higher science for you, but just what you need to know at this level is that these particles will go into the cell, and there's a protein that's going to take it in, but it uses energy to push that particle or move that particle into the cell. Similarly, if there's a large particle outside and it cannot pass through the semi-permeable membrane, it will have to pass it through to the outside by using energy. And energy often we refer to that as ATP. So when you see the word energy, you think of ATP. And that is basically active transport. So just to summarize